Hey, and welcome to the webinar entitled Creating ODRL Policies for Data Sharing. My name is Chris Maidens and I'm a Research Fellow in the Data Management Group at the University of Southampton. In this webinar, we introduce the concept of machine-readable data sharing policies and the Upcast tool provided to simplify their creation. The work presented here has been actioned within the EU Upcast project. That is, the universal platform components for safe, fair, interoperable data exchange, monetization, and trading. Upcast project provides a set of universal, trustworthy, transparent, and user-friendly data market plugins for the automation of data sharing and processing agreements between businesses, public administrations, and citizens. These enable actors in common European data spaces to design and deploy data exchange and trading operations, guaranteeing the outcomes illustrated here. In summary, Upcast seeks to provide a set of tools and services to help ease access for actors wishing to share data across common European data spaces. In this presentation, we will give a brief introduction to the creation of machine-readable ODRL policies for data sharing, explain some of the high-level issues that use of these policies addresses. We'll provide an overview of the plugin itself. This is a user-friendly ODRL policy creation and management tool to simplify the job of ODRL policy creation. We'll then give a quick demo of the tool being used. And finally, we will summarize key points discussed and provide a few links to the key relevant resources referenced in this presentation. So what is a data sharing agreement? This is a wide-ranging term used to describe a legal document outlining the terms and conditions for sharing data between two or more parties. It specifies the purpose, type and duration of the data access and defines responsibilities of each party. It will also detail how the data should be handled and secured to ensure compliance within data protection laws. This type of agreement is required to prevent misuse, ensuring accountability and trustworthy data use. Machine-readable data sharing agreements are simply data sharing agreements that can be interpreted by machines while retaining human readability and legal standing value. So why does this matter? In essence, a codification of data sharing agreements into a machine-readable form allows for increased automation. We can use machines to automate elements of the costly and time-consuming process of checking, enforcing and auditing compliance. Where additional data meets standardized criteria, the incremental overheads of inclusion can become minimal. Additionally, machine-readable policies facilitate more efficient automation of collaboration and negotiation between parties. The associated application of increased standardization across policies creates the potential for enhanced harmonization and interoperability between the various ecosystems that currently exist. The Open Standards Group W3C has spent a number of years developing ODRL, a standardized machine reading policy expression language. This provides a flexible and interoperable information model, vocabulary and coding mechanisms for representing statements about the usage of content and services. This has been adopted as a standard in many sectors. In summary, a policy is represented as a set of rules defining what a user is permitted to do, what they are prohibited from doing, and what, if any, duties they are required to perform in using the data. A rule is made up of a number of elements specifying the target data asset, the actor, the action, the actor wishes to perform, and the purpose for performing this action. A policy, rule, and any of the rule elements may be further refined through the specification of additional detailed constraints. This all provides a powerful and flexible framework for specifying details of policies. In order to address the concept of negotiation and data exchange, ODRL supports two policy types: the data offer, indicating what the provider wishes to offer, and the data request, indicating what the consumer wishes to request. A negotiation protocol may then provide a framework for agreement on a single set of conditions that are acceptable to the involved parties. But this creates two particular challenges, and these challenges are what the tool presented here seeks to address. Firstly, in order for the ODRL standard to be flexible enough to support a wide range of use cases, the encoding and serialization methods are inevitably complex. Our tool removes this complexity through an easy-to-use graphical user interface. Secondly, if we wish to compare two policies to understand the difference, this is also complex. For this, we provide an easy-to-use API that will return a textual summary of the differences between the two policies. Provide an overview of main tool components being discussed in this webinar. We will follow this with a brief demo focusing on the policy editor. There are three components to discuss here: the policy editor API, and also the policy editor comparison API. Firstly, the policy editor. This is a user-friendly web-based interface allowing non-technical users to create, update, store and share ODRL policies. In particular, this supports user integration of domain-specific ontologies to refine the vocabulary available to users when creating policies. It supports multi-user login and policy management, and also user-based management of multiple policies and domain-specific ontologies. Open APIs are also available to support community of sharing of policies and ontologies where users have elected to make these public through the policy editor service. Users may also directly integrate the policy editor interface with user workflows via URL. We will demonstrate the editor later, but a quick word about the management interface. After a user logs in, they are presented with the interface. This allows users to manage multiple policies and domain-specific ontologies. They may also choose to make these policies publicly available as they wish. The interface is reasonably self-documenting and provides standard functionalities. There are two main tabs, the Policy tab and the Ontology tab. For the Policy tab shown here, the user may create new policies or create new policies based on previous policies by clicking the given button. Edit an existing policy by clicking on the name policy. Download the policy to a local machine by clicking the given button. Delete the policy or make the policy publicly available or private using the Publish Protect button, depending on the current state. For the Ontology tab, this is similar approach, but the user may only add new ontologies by uploading new TTL or RDF files, delete existing ontologies, or choose to make their ontologies publicly available. Please also note that all users will have access to the default ODRL DPV ontology. This is a refinement of the standard ODRL and DPV policies to address known detailed compatibility issues when using these together. The DPV ontology relates directly to privacy. As mentioned previously, when a user is developing policies and ontologies, they may wish to share these with the community through the editor management interface. If they choose to do this, then they will become accessible through the policy editor APIs. These are a set of REST APIs that provide functionality required to access the items. 4 key APIs are provided: the ability to list all the policies and ontologies available along with their IDs, and the ability to access the content of these policies and ontologies via the ID. All the REST APIs are self-documentary as shown below. University of Southampton also researched and developed an interface to provide structured textual responses, giving users an understanding of the difference between the two policies. This is particularly useful during a negotiation phase between a provider and consumer to understand the difference between an offer and a request, helping streamline and accelerate the negotiation process. This is accessed through a REST API and is illustrated below. We will now briefly show the policy editor using a small example to illustrate the key features. The system supports multiple users and normally you would log in, but here I've already done so and we are at the user management page which was described earlier. Here there is an example policy already existing and I will use this for illustration, so I'll click here and enter the policy edit screen. This policy applies to a single data asset. This is specified in the target element. The policies broadly describe the permissions and prohibitions that a provider requester wishes to allow against a single data asset. A set of rules are built to describe the policy. The vocabulary used throughout the editor is driven by the ODRL DPV ontology and any additional custom ontologies created by the user. Here we have two rules specifying the policy for this data set. We have a permission rule here and a prohibition rule here. So within each rule, we specify the rule by selecting a rule type, in this case permission. We say who this rule applies to, the actor, in this case a student. What action this rule applies to, in this case analyze data. And we also want to understand why this action is being applied, that is the purpose. As you can see, the options provided for each of these are easily accessible through the drop-downs. So each of these items has a selection of vocabulary which can be chosen from. I'll give a brief example in a minute of how this approach can be used to allow a user to add their own domain-specific values over and above the base ontology provided. So we can go further and apply refinements against each of the rule elements to tighten their specification further. So we already have an example here where the academic research needs to have approval, and it's worth noting that these refinements are also context dependent. So a different drop-down may be present at a different set of options. And these are also expandable using custom ontologies. The query refinement at the bottom here is particular interest as this provides a mechanism for applying rules to just a subset of the overall data target. The example given here is of course simplistic for the demo. We're just extracting a subset based on columns. We may also add constraints that apply to the rule as a whole. Together, both these rules form the policy for the given data asset. We may easily add new rules and remove unwanted rules. So by pressing that, we'll now see an extra rule having applied here. I can remove it. And we may also save the policy at any point, save the policy as a new policy, or download the current policy as an ODRL file. So as mentioned, the drop-down values throughout the editor are driven by the underlying ontologies. Currently in this session we're only using the default ontology. As an example, we can look at the actions drop-down here. And if we go through that, we'll see they're in alphabetical order that there's no grid-based clustering option shown here. And also, if we have a look at the refinements associated with that action, we only have finish time and start time available to us to refine this particular action. So can we now look at an example of adding a domain-specific ontology. So if we go back to the index page here, and then we go to the ontology tab, we can upload a new ontology. Here we supply with the editor an example custom ontology, and that's the one I'm going to load up here. We have loaded it successfully, and if we just refresh that page, we'll come back to here and see that the new ontology is present in the main index page. So now if we go back to the edit, policy edit, and refresh this page so it's aware of the new ontology. We now go to actions and we'll find that grid-based clustering has now become available. And if we were to pick it and add a refinement, we now have a specific additional refinement option of has threshold density, and this has come from the example ontology. And in general, all drop-down options may be tailored in this way. So I hope that's given you a brief overview of how the policy editor works and the key components and how these are useful to a user when building ontologies and policies for their own particular use cases. So to bring this presentation to a conclusion, we have three main takeaways from this presentation. Number one, the policy editor provides a user-friendly interface to help non-technical users create machine-readable ODRL policies. We also provide the facility to share policies and ontologies between users to create domain-based communities to share templates and standards. And we support the complex problem of machine-based negotiation through API-based ability to reliably compare offer and request policy descriptions. Here are a few links to related resources that give more background on what we've spoken about here. In particular, we have the Upcast project, the ODRL information model, and the privacy editor demo. And so thank you very much for attending this webinar, and I hope it gave you a good overview of this set of Upcast tools.